Okay, this is your video for module number 14. We're going to be getting into some polynomial functions here, which you did in Algebra 2. I believe it was towards the end of Algebra 2, so you might remember some of these things like finding the zeros and the multiplicities, which is your first topic, and the end behavior, which is going to be the second topic here. So hopefully some of this looks familiar to you. But for this one, finding zeros and their multiplicities given a polynomial function written in factored form. Okay, so what that's going to look like is something like f of x is 8x cubed, x minus 12 squared, x minus 5, x plus 4 cubed. Okay, so I could expand this all out. But this is in factored form. Okay, if I were to expand it all out, I'd have to square that x minus 12. I'd have to cube that x plus 4. It would be a lot of work to expand it. Okay, so they're just going to give it to you in factored form. I would strongly encourage you to graph this in Desmos to see, or on your calculator. Desmos is kind of a nice handy tool. And if you want me to show you how to use that, I definitely can. But these are good ones to graph, just so that you're kind of understanding how these functions work. What does that mean if you've seen x minus 12 squared in your equation? So I would strongly encourage you're going to have a deeper understanding of these if you look at the graphs, okay? But your zeros, just like when you had quadratic functions, using your zero product property, okay, just set each factor equal to 0. So your first one, if 8x cubed is 0, that means x would have to be 0. Your second one, x minus 12 is a factor, so x equals 12 would give you a 0, right? X minus 5, so x equals 5 would give you a 0. And x plus 4, so x equals negative 4 would give you a 0. Any of those x values, when plugged into the expression, would make the entire expression equal to 0, okay? So for this problem, those are your zeros, but now they ask you also the multiplicity, okay? So if you look, for example, that last one that we just did, x plus 4, well, it's cubed, which means technically x plus 4 is a factor 3 times, okay? So we would say x equals negative 4 is a 0 of multiplicity 3, okay? Just x plus 4 is a factor 3 times, so x equals negative 4 is a 0 3 times. Okay, so then rather than writing negative 4 3 times, you just say negative 4 is a 0 with multiplicity 3. Okay, your x minus 5, that's just one guy there. If you want to put an exponent on it, it's 1. Okay, so this would be a multiplicity 1. Okay, and x equals 12. That guy's a factor twice, so that'd be multiplicity 2. Okay, and then your x cubed, remember, it doesn't really matter what that 8 is out front. All we really care about is that it's x cubed. So x equals 0 is a 0 of multiplicity 3. Okay, so there you go. That's how you find your zeros and their multiplicities. Okay, our next one is end behavior. So we have determining the end behavior of the graph of a polynomial function. Okay, for this, you just need to keep two things in mind. You need to remember what the graph of x squared looks like, and you need to remember what the graph of x cubed looks like. So x squared looks like this, and x cubed looks like this. Okay. Now, how that helps you is all functions with even degree. And remember, degree is the highest power. Okay, and I should say all polynomial functions. With even degree, we'll have the same end behavior as y equals x squared. Okay, and again, we only care about the ends. All right, so there could be a lot of things going on in the middle there, but at the end, we're pointing up in both directions. Okay, or if it's a negative x squared, we're pointing down. Okay, and then here, all polynomial functions with odd degree will have the same end behavior as y equals x cubed. In other words, we'll look in opposite directions here, okay? So to the left, it's pointing down towards negative infinity, and to the right, it's pointing up towards positive infinity, unless it were a negative x cubed, and that would flip, okay? So we're going to look at some examples here. Okay. The first one, we have f of x is 6x cubed minus 9x squared plus x minus 3. And the way that they write these out for you to choose from, they choose your options. You like bubble in what you want. Okay, falls to the left and rises to the right. Okay, and then they have rises to the left and falls to the right. Okay, and then they have rises left, rises right, and then finally they have falls left and falls right. So you choose what you want for each of these. Okay, so for our first guy here, again, all we care about is the degree, the highest exponent. So we don't care about those at all. All we care about is the 6x cubed. The degree is 3. And that coefficient there, that's 6, and it's a positive function. Okay, so it's going to end exactly like your function y equals x cubed. Okay, that's all we know, is that to the left it's down, to the right it's up. All kinds of things could be happening in the middle, but all we care about is the end behavior. Okay, so for this particular one, it falls to the left and rises to the right. Okay, so we'd bubble that in. All right, we'll do another one because they give you like 3 at a time. Okay, the next one, and I'll switch colors here so that I don't get too confusing. The next one is f of x is negative 5x to the 6th minus 6x to the 5th plus 3x to the 4th plus 6. Okay, again, we don't care about anything other than the highest degree. Okay, and I don't think they're going to try to trick you or anything, but make sure you look at all of them. You know, maybe that last one, you know, instead of 3x to the 4th, maybe it's 3x to the 14th. Then that's the highest degree, and that's what we care about. Looks like they're doing these in standard form where the highest degree term is always first, but double check that. Okay, so we don't care about those. All we care about this. The degree is 6, which is even, and we have negative coefficient. Okay, so this is going to operate much like y equals x squared, but with a negative out front. Okay, so that'd be a parabola that opens down. Okay, so we know y equals negative x squared looks like this. Okay, this particular function could be doing all kinds of things in the middle, but that's how it's ending. Okay, so it falls left and falls right. Okay. All right, the last one they give you is one in factored form. Just throw you off a little bit. f of x is -3, x minus 1, x plus 5 squared. Okay, so now you have to think about if I were to expand, then I would have -3 times x minus 1 times x squared plus some junk. Okay, it doesn't really matter. I mean, it's x squared plus 10x plus 25, right? It doesn't even matter. Okay, and then if I kept going, if I were to expand the x minus 1 times that x squared plus whatever, I'm going to have an x cubed, right, plus some more junk. And it doesn't matter what, because all we care about is that biggest degree that you're going to get out of there. Okay, your shortcut here is to just add up these two powers. Okay, so a little tangent here. If I had like, if I had 2x plus 5 cubed, x minus 4 to the 4th, maybe even, let me change that 2 to 2x to the 8th, x minus 5. If I had something like that, all I would do is count. I'd have an 8 on that x. I'd have a 3 on this x. I'd have a 4 on this guy. And I'd have a 1 on this guy. So the degree here would be 8 plus 3, which is 11, plus 4, which is 15, plus 1, which is 16. Okay, so it'd be 16. And I don't have to expand that all out to see that. Okay, so back to the one that we have here. The degree is 3, which is odd. And we have a negative coefficient. So this guy is going to operate much like y equals negative x cubed. Okay, it's going to have the same end behavior. So your negative cubic, well, x cubed, I almost started drawing x cubed. This is what x cubed looks like. So we're looking like this, negative x cubed, right? It flips. So we're going to have the same end behavior as this guy, which means rising to the left, falling to the right. Okay, so that's what I would bubble in for that one. All right. Okay, let's take a look at the next one. The next one is determining end behavior and intercepts to graph a polynomial function. Okay, so this puts a lot of things together here. And hopefully you remember this from Algebra 2. I always thought that this was one of the more fun topics because it's kind of like a puzzle and you put all these little pieces together. Okay. So an example that they're using here is we have f of x equals negative x plus 3, x plus 1 squared, and x minus 1. Okay, now the first thing we do is from the first topic, find your zeros and their multiplicities. Okay, so again, x equals negative 3 would be a 0 with multiplicity 1. Okay, x equals negative 1 is a 0 with multiplicity 2. And x equals 1 is a 0 with multiplicity 1. Okay, now what that means is we're going to hit the x-axis at those points. Okay, so I'm going to start graphing to the right actually. Okay, so at x equals -3, we're going to have a 0. At x equals -1, we're going to have a 0. And at x equals 1, we'll have a 0. Okay. Now, the next thing is you have to figure out what's going on at those zeros. You might remember if the multiplicity is 1, it goes through. If the multiplicity is 2, it bounces. Okay, the multiplicity is 3, you might remember it wiggles. That's kind of what we talked about it when I taught Algebra 2. Okay, in other words, it acts like the function of that same degree. Okay, and let me say that again because it's really important. It acts like the function of the same degree. So first degree function, it's linear. It just goes straight through. Okay, a second degree function is quadratic. It's going to bounce. Okay, third degree polynomial, that's a cubic function. You're going to have a little wiggle. It's still going to go through, but it's going to wiggle a little bit. Okay, and if you remember anything more than that, like fourth degree, it also bounces, but it's a little bit flatter when it bounces. I don't know if they're going to give you anything more than 3 or even 2. But if that comes up, let me know and we can talk about it. Okay, so you've got your zeros and your multiplicities, but now the thing is, we know it goes through at -3, but is it going to go through like this? Or is it going to go through like, let me see here, this? And we don't know. That's where your end behavior comes in. Okay, so your end behavior, so we're putting together the last two topics, right? So your end behavior for this one we'll have our degree here again, okay, is going to be 1 plus 2 plus 1, okay, so that's going to be 4, and we have a negative coefficient, okay, so it's even degree and negative. It's going to have the same end behavior as a negative x squared. Okay, and so that puts all the puzzle pieces together. All right, we're gonna, to the left, it should point down, and we know we should end pointing down. That can kind of be our little check here. So we're gonna go through it at -3. Okay, and it's your 0 of multiplicity 1, which means we're gonna go straight through. Okay, and then at -1, the multiplicity is 2, so we know we're gonna bounce. Okay, and then at x equals 1, the multiplicity is 1 again, so we're going to go back through. And just like we said, it should end down. That's going to be a nice little check there that you did it right. Okay, the last little piece of the puzzle that I think they might want you to get is the y-intercept. Yep, they do. Okay, so maybe I got a little bit ahead of myself here, but we're going to get your y-intercept. Yeah, because they give you a grid to graph it on. Okay, but your y-intercept, it's pretty easy to find. Okay, let me kind of highlight all these. Your y-intercept is when x is 0. So f of 0 will be -0 plus 3, 0 plus 1 squared, 0 minus 1. And just be really careful with your negatives. Okay, so -3, 1 squared, which will just be 1, and then -1. Okay, so we're going to end up with well, I guess 3 times 1 times -1. Okay, the two negatives will cancel each other out, so it's going to be +3. Okay, so this point here will be at 0, 3 when you're graphing. All right, and that's another check. You know, if I got -3, then I would know I did something wrong. If I got that the y-intercept was -3 because it doesn't match up with the graph. And then that's at 1, 0, -1, 0, and -3, 0. Okay, so those three pieces, your zeros and their multiplicity, your end behavior, and your y-intercept, it should all come together and nothing should contradict like I said, if I got a y-intercept of -3, I know something went wrong. Either my y-intercept is wrong, or some of the end behavior is wrong, or my zeros and their multiplicity is wrong. I can check it, okay? All right. Next one is matching graphs. So that's probably going to be a little difficult for me to show you on here, but that's okay. We have matching graphs with polynomial functions. Okay, so they give you two functions. Okay, so the first one that they give you is f of x is -3, x plus 1 squared, x plus 3 squared, and h of x is x cubed minus x squared minus 6x. Okay, you don't have to graph them yourself. Like I said, they give you some graphs to choose from. They actually give you, let's see, they give you 6 graphs, and you have to choose from them. Okay, so I'm going to do my best here to kind of show you what they have here. So they have graph A, B, C, and then they have D, E, and F. Okay, and then to my best of my ability here, I'll do this a little darker. Okay, graph A looks like this. Graph B looks like this. Graph C looks like this. D looks like that. E, let's see, I think it kind of looks like that. And then F looks like that. Okay, so you can kind of like process of elimination a little bit here. There's different ways you can kind of think about this. Okay, I'm going to look at h of x first because that one's a little bit maybe easier. I don't know. We'll see. Okay, so it's third degree, and it's positive. Okay, so I know that's going to be like a cubic function. Okay, at the very least, it'll down to the left, up to the right. Okay, so I can eliminate A, B, D, and E. Okay, so I'm down to C and F. So the next thing to do is just think about points. Specifically, the y-intercept is going to be a really good clue here. Okay, so the y-intercept is when x is 0. Okay, and I can see that h of 0 would be 0. So the point on it should be 0, 0, which I see on graph C, and I do not see on graph F. Okay, so C is going to be h of x. Okay, there's my choice for h of x. All right, then we get f of x. I'm gonna use a different color for this guy. We'll do green maybe. Okay, this one now, the degree is going to be 4. Okay, so 4th degree, which is even. Okay, and it's negative, which means it's going to act like an upside down parabola. So down to the left, down to the right. Okay, so again, I can eliminate A, B, D is a possibility. C is obviously not it because I already chose C. D is a possibility, E is a possibility, not F. So I'm down to D or E. Okay. Now, the next thing to look at, I can look at a couple things. I can look at, first of all, the zeros would be x equals -1 and x equals -3. And both have multiple, I don't know why I spelled both like that. Both have multiplicity 2, which means they're just going to bounce there. Okay, so that Both bounce. So at x equals -1 and x equals -3, I should have that bounce there, which means E's not my guy. Okay. The other thing I could do too is the y-intercept. Again, where x is 0. Okay. So I could have f of 0, which would be -3, 0 plus 1 squared, 0 plus 3 squared. So -3 times 1 squared times 3 squared. So that's -27. Okay, which is definitely not E. E has a y-intercept at 0, 0. D, the y-intercept is clearly much farther down. So further confirmation that that one is going to be D. Okay, kind of fun to figure those out, right? All right. Okay, next one. Writing a quadratic function given its zeros. Okay. Oh, this one's going to be really straightforward for you guys. Okay, write a quadratic function whose zeros are -1 and 12. Okay, well, you're kind of working backwards now, right? If a 0 is -1, that means a factor would be x plus 1, right? Because if x plus 1 is a factor, you get the 0 of -1. And x minus 12 would also have to be a factor. Okay. Again, you're just thinking backwards. What would make 12 be a 0? And that is if x minus 12 is a factor. And you don't even have to expand them. Okay, your final answer, f of x, is x plus 1, x minus 12. That is it. As simple as that. Okay. Next one. Bring it back up here. I lost it just a second. All right. The next one we have is finding a polynomial. So far, nothing here is anything that you didn't do in Algebra 2 already. So that's kind of nice. I hope you remember how to do them. Okay, so we have finding a polynomial of a given degree with given zeros, and they classify this too as just real zeros. Okay. Later on, maybe we'll get into the imaginary zeros. We'll see. All right. Okay, so we want a polynomial of degree 4 with zeros 0, 4, -7, and 8. Okay, it's just like what we just did. Okay, it's just you have two more factors. All right, if those are your zeros, then your factors would be x minus 4, x plus 7, and x minus 8. Okay, so your answer is just f of x is x times x minus 4 times x plus 7 times x minus 8. Easy peasy, just like that. Okay. Next one. All right, we have polynomial long division. You guys learned this using the area models in your CPM class. Okay. You are going to have Alex do it a different way. I will show you both ways. And you can decide. And I learned it the first way, the way that Alex does it. I like the way you learned it too. I think in some ways, if you are good with long division, like when you first learned it, when you were in like whatever, 6th, 7th grade, The first way might make more sense, but you really can do it either way you want. I'm not sure what classifies this as problem type 1, but we'll see. Okay, so they want you to do 4x squared plus 29x plus 31 divided by x plus 6. Okay, and they do tell you there will be a quotient and a remainder. Okay, so maybe that's what makes it problem type 1, that there's a remainder. All right, so first method, the way I learned it, you do long division. Okay, so you get your little house there, right? And 4x squared plus 29x plus 31 goes underneath, and the x plus 6 goes on the outside. Okay, and then much like when you did long division, you just look and see how much the first digit kind of goes into the first digit of the underneath. So you've, sorry, how many times does x go into 4x squared? Okay, so you would need a 4x there. All right, so your 4x, and you place the value matter, so your 4x would go right here. Okay, and again, how many times does x go into 4x squared? Maybe a better way to think about it is x times what gets you 4x squared. Okay, so I need a 4x, and then just like long division, you then multiply what you just wrote up top by this guy. Okay, so then you get 4x squared plus 24x. And then you subtract. Okay, you're going to have 0 plus 5x, and then you drop the 31. Okay, now you do x into 5x, so x times what is 5x, and that's going to be 5. And then you multiply through, so you have 5x plus 30, and then you subtract to get your remainder. Okay, so your quotient, oops, sorry, that was method 1. Your quotient is 4x plus 5, and your remainder is 1. Okay, now the way a lot of you learned how to do it in Algebra 2 is with that Polydoku method, where you set up an area model, and we knew that one side was x plus 6. You had to figure out what the other side would be to get to your goal of 4x squared plus 29x plus 31. Okay, so if you remember, you put the 4x squared in right away. And then from there, everything kind of filled in. Okay, so in order for us to get a 4x squared there, 4x would have to go here, which means 24x is here. Okay, so we took care of our 4x squared. Our goal is 29x, and we have 24x, so we knew that this had to be a 5x. Okay, so that would get us our goal of 29x, which means the 5 had to go here, which gave us a 30. And then there's your remainder, the 1 that you still need. Okay, so this still gets us our quotient of 4x plus 5 and our remainder of 1. This is the remainder here. Okay, so hopefully you remember that a little bit. Okay, we got 2 more problem types for long division that they're going to throw at us here. Problem type 2. Okay, so for this one, we have 6x cubed plus 17x squared plus 11x plus 19. And we're going to divide by 2x plus 5. Okay. I'm going to do this one. How do we want to do this one? I'll do this one your polydoku way. Okay. I feel like most of you might choose that way, but if you do want to spend more time doing the method 1, I can spend some time with you to help you. Okay. We're going to put in the 2x plus 5, and your goal is 6x cubed plus 17x squared plus 11x plus 19. Okay. You put the 6x cubed and then start filling in. All right. If that's a 6x cubed, this needs to be a 3x squared, which makes this 15x squared. Okay. So we got our 6x cubed. Our goal is 17x squared, so we need another 2x squared to get there. And then we have our 17x squared. Okay, and for that to work, then this needs to be an x. May have to start another video here in a little bit. So then we have a 5x here. Our goal is 11x, so we need 6x. And then we've got our 11x, which means this has to be 3, which means we'd have a 15 here. Our goal is 19, so our remainder would be a 4. Okay, so quotient 3x squared plus x plus 3, and remainder, I don't know why I spelled that weird, remainder 4. Okay. All right, let's see what we got next. We have polynomial long division type 3. Okay, so they're just having you write your answer a little bit different here. And if you remember, we did this too in Algebra 2. Okay, so they just want you to write it a little different. So we divide 2x to the 4th plus 4x squared minus 17 minus 6x cubed. Oh, that's not. Oh, I guess it is right. Okay. I was going to say, why'd they put the 6x cubed on the end? I think they're just trying to trick you. Okay. But divided by negative x squared plus 2x minus 3. Okay. And they want you to write it as quotient plus remainder over negative x squared plus 2x minus 3. And that's all you really need to do. Like, you're still just finding the quotient and remainder, and then you're writing it in the way that they want you to write it. Okay. So again, we'll set up our box here. And we're going to have 3 rows now. So we have negative x squared, 2x, and negative 3. And our goal is 2x to the 4th plus 4x squared minus 17 minus 6x cubed. And we're just going to want to rewrite that. Okay, we want those in order from increasing to decreasing degree. I'm sorry, highest to lowest degree. So we're going to rewrite that as 2x to the 4th minus 6x cubed plus 4x squared minus 17. Okay. This one's going to get a little bit trickier because you also might have noticed that we're missing any x term in that goal. Okay, so remember you kind of put a placeholder there. So I'm actually going to rewrite that one more time. Is 2x to the 4th minus 6x cubed plus 4x squared plus 0x. Let's see, it's getting glitchy on me. Minus 17. Okay, Now we're ready to go. All right, so our 2x to the 4th is going to go right there. Okay, which means we need a negative 2x squared. Don't let the negatives throw you off. It's no different than, if negative times negative is positive. So then I'm going to have a negative 4x cubed here and a positive 6x squared. Okay, so I've gotten my 2x to the 4th. Now I focus on the x cubed, all right? I want a negative 6x cubed, and I have a negative 4x cubed, so I need a negative 2x cubed. And then I've gotten that guy taken care of. And I can fill in more, so I need a negative 2x right there. Actually positive, right? Positive 2x. Okay, so when I multiply it by the negative x squared, I get negative 2x cubed. And then I'll have 4x squared here. And then I'll have a negative 6x. Okay, now I take a look at my 4x squared to figure out what I want to put in the next box. My goal is 4x squared, so I need 0x squared here. Okay, and we're going to use that placeholder, all right, which means if I went 0x squared there, I need 0 here. I feel like I messed that up. Did I mess that up? Oh, I did mess it up because, all right, first time through when I was doing my x cubes, hold on a second here, let me get the right color here. Okay, so when I was doing my x cubes, I needed to look at these, right? I'm doing my x squareds, I need to look at this entire, all three of them, that entire diagonal is going to be my x squareds. Okay, so I have 10 x squareds, and I only want 4, so I'm going to do a negative 6. Okay, and that will give me the 4x squared that I want. Okay, so then I need up top just a positive 6. Okay, so that positive 6 times the negative x squared gets me the negative 6x squared. Then I'll have 12x here, and then I'll have negative 18 here. Okay, now we're getting into our remainder. So we have reached the ones place there, right? So anything left that I still need is my remainder. Okay, so this is my quotient. My quotient is negative 2x squared plus 2x plus 6. So my remainder, let's see here, I have a negative 6x and a positive 12x. So that is 6x. I want 0x. So I need a remainder of negative 6x. Okay, that'll get me my 0x. And I have a negative 18 in my box here. Okay, and I want negative 17. So I need a positive 1, plus 1. Okay, so this is my remainder. My remainder has 2 terms in it. My remainder will be negative 6x plus 1. Okay, so now if I write it in the format that they want, my answer is going to be negative 2x squared plus 2x plus 6 plus negative 6x plus 1 over negative x squared plus 2x minus 3. Final answer just like that. Okay. All right. Then let's see here. I think I might stop for a second here and start another video. Yeah, I'm going to stop this here, and then I'll get you guys another video here. Just a second.